Assalamualaikum and welcome back. So we are going to continue with the second part of the video under frames and machine. So in this part, I will explain on how to solve the problem for frames first. Okay, so for FBD, we can take either overall FBD, the FBD for two force member, the pulley, or the member of multi-force member, depends on the question. So basically not all FBD are required, right? So we have to depends on the question. What are the forces that they need to find? Okay, so that's mean not necessarily we have to draw all the FBD unless the question asks you to do so. Okay, so first thing first, in order to solve this problem, let's say for example I came up with this question. Okay, this one, this is the question. Okay, we have three force member ABD, multi-force member ABD, and then we also have a two force member BC, and we have a pulley and also a load here with a tension wire here, right? So when we find when we want to find the value of the forces, we have to use the FBD, of course, right? Then we have to apply the equilibrium equation for rigid body. Okay, so after but whatever it is, we have to make sure that our FBD is correct. If if our FBD is wrong, and of course our value is wrong, right? So first we have to take out all the forces, in external forces, internal forces that are in the problem. Okay, for example, this question here, we have AX and AY. Why we have AX and AY? Because it is a pin connection, right? So we know that before this, for the pin, we have two components, AX and AY. And then for roller, we have one perpendicular, right? And then for two force member here, BC, we have one force, okay, FCB or FBC, same. And then we have the tension from the rope. So the tension can be assumed that it is equal to the weight of this material. W equal to T, right? This is the basic concept. Okay, then let's say we have here a few unknown, but we only have three equation, right? We have summation of fx equal to 0, summation of fy equal to 0, and summation of moment at any point equal to 0. Okay, so basically when we want to find at least not more than three unknown, then we can use this three equation. More than three unknown, we cannot solve, right? So if let's say the overall FBD has contained more than three unknown, I think we just ignore the overall FBD. No need to draw. No need to calculate the value based on the overall FBD, because we only have three equation. So we only can find three unknown. When we have more than three unknown, we cannot solve the problem, right? We have to look at the other FBD at the other member. Okay, so other than that, we also can come up with the pulley FBD for the pulley, and then FBD for two force member, as well as FBD for multi-force member. Okay, so next when we want to come up with the FBD, we have to make sure that there is only the point or the component cannot use the same direction. Okay, so let's say here we have two force member FBC. Basically this one we assume it is a tension force. Normally we assume it is a tension force. For two force member, assume two force member assume tension. Okay, so and then when we apply at the another members, we have to use the different direction, as you can see here. FBC here facing to the right, now is facing to the left. We cannot use the same direction. Okay, same goes to the point D here, the pulley point. Okay, before this we use this one, dx on the right, to the right, and dy facing outward, right? When we apply to another members, we have to use different direction. This is the requirement, right? Same point B, use same force, same line, but opposite direction, because we apply the Newton's third law. Okay, where we know that under Newton's third law, it has to be reaction and action kind of process, right? That's why we have to apply different direction when in different FBD lah, FBD member. So different member, different direction. Okay, okay. But for AYAX, okay, it is different situation where this is from the overall FBD, so it is excluded, right? Okay, so previously we know that the overall FBD is included with the A, Y, and AX, but for this member we still using the same direction. If another FBD member also have the same joint, then we need to use different direction. Okay, okay, next example. As you can see here, we have one multi-force member, one pulley, and one cable. Okay, so for overall FBD, we know that we have to put it here AX and AY due to pin connection, and then we have tension and force P. Okay, so here you no need to include the component, the force component force of B, point B. So this is just for overall. So untuk overall, we only focus on the forces that are absolutely there. Okay, so yang ni memang yang standard lah. Okay, yang mana kita we have to come out with the standard forces that should be there for overall. And then after that baru kita distribute into the section by section. Okay, so for this one we have to come up with the multi-force member FBD as well as for pulley. Okay, so for this one, same, we have to apply the Newton's third law.